thank you everyone for joining this webinar as a part of Kiran C. Patel Center for Sustainable Development. And today we have Miss Swagata Dey as our speaker. And let me briefly introduce her before we get started with the presentation. So Miss Swagata Dey is a New Delhi-based researcher with a decade of experience in the domains of atmospheric chemistry, air pollution, climate change, and materials chemistry. She leads the Local Air Management Plan, LAMP, for Environmental Defense Fund in India, where she focuses on the localized sources of pollution in the hotspots and their mitigation. She investigates how hotspot management can help city governments reach NCAP or National Clean Air Program targets. Prior to EDF, she has been associated to Center for Science and Environment, New Delhi, as the Deputy Program Manager for Clean Air. And even before that, she worked as a researcher in the Center for Sustainable Materials Chemistry at Oregon State University, USA. She was also a university fellow at the Ohio State University. Ms. Dey holds a research-based MS from the Ohio State University and MSc in Environmental Sciences from Terry University, New Delhi. And before I pass on the virtual mic to our speaker, all of you can put in your questions whenever you have in our Q&A box, and we will start taking them one by one after the end of the presentation. So with that, we can get started. Yeah.
Right. Thank you, Professor Patel. I think that was too much of an introduction. I'd start by saying I am also a citizen, a daughter who's seen parents suffer through the pollution crisis. And of course, this has now become my it's not only my professional work, but somewhere I'm very personally invested in this. So I'm going to talk about role of technology and instrumentation in air quality management in India. I'm going to talk about what are the methods that are available and how it all comes together when we are looking at overall air quality of a city. I work for Environmental Defense Fund. We are an NGO. And just a brief about EDF. It's an old, very old organization, more than 50 years old. It started in the United States in the 1960s. They were responsible for managing the osprey population and preventing it from going to extinction by banning the use of DDT. And they've been active ever since. And lately, they're very active in California, and they're working with US EPA for electrification and vehicular pollution and such stuff. We have a global presence. We, of course, centered in the US, but about 1,200 staff as of this year. We are all over the world, and we also have presence in Europe, and this map is not updated. And in India, we have a small team. This is our president, Fred, who's talking about the methane satellite that you can read about. This is one of our primary initiatives called hyperlocal mapping. This is essentially, you have the Google Street View card, which maps pollution at the localized or the block level in the US. And a similar study was done called Breathe London, which is something many of you might be very, very familiar with. And this was supported by Mayor of London, Sadiq Khan. And this is still on, and this has been a very, very successful project. In India, we, of course, have a similar project called Local Air Management Plan, where we work with city governments to map pollution sources in the microenvironment. We partner with NEDI, TERI, IIT Delhi, and IIT Madras. We've successfully launched the INDAIR, that is a repository of all air pollution research in India. We've partnered with NEDI and CPCB, and you can actually look this up as well. We work with TERI to do the Sustainable Urban Freight Coalition, where out of all the vehicle types and transport emissions, we focus on freight. There is IDEA, which is India's first open source energy model. And this is in conjunction with the IISc Bangalore and Jadavpur University. And then in Indore, we have the Clean Air Catalyst, which is a multi-stakeholder consortium for cleaner air for the city. Apart from this, we have a lot of knowledge products. EDF believes in strong partnerships, and we have partners all over India, right from state governments to local academic partners to technical bodies. And hopefully IIT Gandhinagar is going to be a part of this soon. So with that, I will focus on the talk today, that is role of technology in instrumentation. And I will start with what we all know. And I'm told this is a bunch of BTech and master students. So we know, and we keep hearing this, that we are home to the world's most polluted cities. We have health impacts, the obvious ones, asthma, bronchitis, and of course the non-obvious ones, which are now, there is research to say that cognitive ability, dementia, COPD, all of these have, there is air pollution has an impact on these. And so that is there. We know the common emission sources. We know that transport is a major source. Industries are a major source. Power plants are a major source. Garbage burning is a major source. Domestic emissions are sources. We know the common pollutants. We know what is particulate matter, what is sulfur dioxide, nitrogen dioxide. What we also know now is what was not very mainstream is the seasonal impact. So we see a spike in pollution levels in the months of winter. And of course, there's a lot of media noise. And there is also some pollutions that is specific or endemic to summers. So there is a reason behind that. So that is something I'm going to talk about. And till about last year, there was a focus on the Indo-Gangetic Plain. That's the northern part of India. That's Haryana, Punjab, Delhi, Uttar Pradesh, Bihar, and West Bengal. They form the Indo-Gangetic Plain. And because what happens is the air cannot go out because of the Himalayas, there's something called a valley effect. However, if you look at air pollution statistics today, it's very sad, but all of India is polluted. So it's not just the Indo-Gangetic Plain, and it's not just a particular geographical feature. It's overall, our sources are very, very high. So I will quickly go over our standards. We are a country which we've been at the forefront of developing standards. So we have standards for pretty much every type of pollutant, and these are for both industrial, rural, and residential areas, as well as eco-sensitive zones. And the way we measure is that it has to be 24-hourly or 8-hourly monitored values, and 98% of the times these values have to match, and it has to be at least 104 measurements in a year at a particular site taken twice a week. So if you're breaching the standard once a year, that is not breaching. It has to fall in these thresholds. In 2014, we also came up with the National Air Quality Index. This is the most common term that we all know about right now. Anybody you ask, you say, oh, Delhi AQI is very high. This is an index that is arrived based on the concentration of certain pollutants, and based on which you get your health advisory. Now, something that is of interest that people talk about, saying, oh, Europe AQI is 25 and Delhi AQI is 300. Yes, of course, Delhi is higher, but as scientists, I encourage you to look at the absolute values, because the way AQI is calculated in other countries and the way AQI is calculated in India is different. And CPCB has very, very firm guidelines. So, but as a measure, AQI is fairly prevalent, and I wanted to just bring this up here. So what happens overall? How do we manage air pollution at a city level? Let's start with that, because that's where we have our jurisdictional boundaries. There is measurements. That is, we do real-time monitoring and we do manual monitoring, and I'm going to talk about both of them. Then we do something called source identification. You have a set number of pollutants that you've seen in your monitors. You try and identify where is it coming from and how much of it is coming from where. And then you get actionable data, so that you get the percentage contribution from each sector. And of course, the seasonal impacts. For example, the way pollutants will behave in winter is very different from how it's going to behave in summer. And then based on that actionable data, we frame our action plans, and there is also an implementation aspect which requires finances. And within data and framing of plans, there is the policy environment. How do you frame policy to help curb emission limits? So that is what I'm going to walk you through. So let us start with a fun activity. This is what we have, a certain type of reference grade monitoring stations, and India has made a lot of progress in this. we have about 379 of these real-time monitoring stations, and they are called CAA-QMS, Continuous Ambient Air Quality Monitoring Station. This link should also be there in your chat, and I encourage you to look it up. This is where you can get this data available for free for all the continuous stations in the country. It's real-time measurement of PM10, 2.5, NOx, carbon monoxide, SOx, ozone, ammonia, benzene, and derivatives, along with meteorological parameters. And it is this data that is usually used to generate your AQI. While this is a widely successful program and it has made so much progress in the past decade, it's an uneven network. That is, if you see already from this map, there is a lot of stations, let's say in Delhi, and the entire state of Odisha maybe has 5. For Gujarat, we have CAQMS in 7 cities, and there are 17 stations, and this is from CPCB as of this morning. Gandhinagar itself, where most of the students, I believe, are based today, has 3 stations. It is expensive, it's labor intensive, and this is what a CAQMS looks like. It's essentially like a metal room, and inside this you have the instruments and you can see the sensors on top. For the students here and for the young researchers, some people had asked, I encourage you to check your cell phone and download something called the Samir app, which is the National Air Quality app by the Ministry of Environment, Forests and Climate Change. And if you download it, it's SAMEER, and it's freely available both on Android and iPhones. You will be able to get the real-time data for your city on your smartphone. So when I say data is freely available, it is actually freely available. And for 4 cities in India, that is Delhi, Mumbai, Ahmedabad, and Pune, you also have the SAFAR network, which is set up by Indian Institute of Tropical Meteorology, Pune, and Department of Earth Sciences, where you can actually get predictions for the next day. There is continuous push to enhance this network, but as I said, it's very, very expensive and it requires trained personnel to operate. But one of the mandates of the National Clean Air Program is to make sure we have maximum coverage of these networks. Next, the more traditional ones is the National Air Quality Monitoring Program, or NAMP. It does monitor the primary pollutants and some others, but the data for this 4 is something you can get very, very easily on the CPCB website. The coverage is far more deeper. There are 883 operating stations across 379 villages and towns. However, like the CAQMS network, this is also mainly urban. I think Punjab and some other places in Western India have stations in smaller villages and tehsils, as we call them, but otherwise it's mainly in cities and towns. It's manual, that is, it's not in real time. It's the filter paper based method where it's carried out twice a week and about 104 days a year on a 24-hour basis, and the guidelines are stipulated by CPCB. The problem is, while this is a fairly robust network, the manual stations, they do not allow daily reporting and real-time management. So you do not get emergency action. You don't see the spikes. The daily spikes are not something you can see very easily. Gujarat, as per the Gujarat GPCB website this morning, we have about 35 stations across 11 towns and cities. So it's quite a robust network for Gujarat. A question that is often asked is, how do we design a network? So this is a set guideline that, that CPCB has said that depending on the population of a town, you need this many number of CAQMS and you need this many number of manual stations. And as you can see, this is above 5 lakh or 50 lakhs, and most of our towns are under that. The number is quite high. And hence, if you see the coverage, it's not very, very good, but I think we've made progress and we're continuing to make progress. So amidst all these very, very sophisticated instrumentation, a new class of instruments have made their debut, and they're getting fairly popular as sensors, and they're essentially lower cost. I emphasize on the term lower, is they're not essentially low cost. They are just slightly cheaper than the reference grade stations. They're easier to install. They allow for higher spatial coverage because they are cheaper. So you can have them at almost every kilometer or every 5 kilometers. However, they require a lot of calibration. And There are a lot of groups who are working on this. So stationary sensors will, give you your pollution trends, and they can be used for model validation. Mobile sensors, they can actually get higher spatial resolution, and it's a good way to measure commuter exposure. So this is a typical stationary sensor that we install. And as you see, since there are no standards, they come in different shapes and sizes. And this is the Google Street View card, which is a mobile sensor. And this is something we've used our own mobile sensors. We put them on a non-emitting or a zero emission vehicle. There are problems with sensors, and that is why they cannot and should not be used for regulatory monitoring. So first of all, the common technologies for particulate sensors, we use the standard particle counting or total light scattering method. And again, this is not an exact, it's not very exact. For gases, we use electrochemical sensors. There are PID sensors for volatile organic carbons and non-dispersive IR sensors for carbon dioxide and carbon monoxide. As I said, there are no standards for sensors yet in this country, and both for the process or for the pollutants, so they cannot be used for regulatory monitoring. So if you see random websites generating AQI using a network of sensors, don't follow them. Just follow what CPCB is saying. The performance of the sensor changes with respect to meteorology. That is, it'll change how it records in a very humid situation like down south, or in a very dry situation like Delhi or where you are, Gandhinagar. And there is a change in performance over time. So though that's the trade-off. So when you say low cost, are they truly low cost? Because if you're having an instrument which is slightly cheaper, but it does not work after 2 years, is it worth investing? There are parameters, and one needs to see what is the concentration range and what is the limit of detection while choosing a sensor. And multi-pollutant sensor are a viable option these days that are coming up. Something that I want you students to take home is are hybrid networks possible? Since sensors are not the option, and the very expensive reference gate monitors are not the option, can we look at a hybrid network, a mixture of both, and try? And that is something up in the air, but that is something we need to look at as a viable solution. Remote sensing is another new technology that has been around for some time. And I refer to this website by Circa at IIT Delhi. Essentially, what you have is satellite images or satellite AOD maps that have then been converted to PM 2.0 maps. There is a rigorous and quite a tough algorithm that I'm not fully aware of, but there is a method. And as of today, you have the maximum resolution of 1 into 1 square kilometer. You can use certain algorithms and drill down to much smaller resolution, but this is what you can get, and you can get the overall spatial PM 2.5 coverage for India. So as you see, this northern India is completely, it's a very high PM 2.5, whereas as we go down, there is much lesser PM 2.5. And then the another way of using remote sensing is especially case of vehicular emissions, where ICCT along with Center for Science and Environment has been working on this, where you measure the vehicular emissions not without directly going near the vehicle. You have a crossroads setup or an overhead setup, and then you're able to measure on-road emissions. And this is also getting popular apart from the regular PUC program that we have. So now we've briefly, very, very quickly covered what are the ways one can measure emissions. But now once we have the measurements, the next obvious questions is, apart from the vehicular emissions, which we know is coming from vehicles, where do these emissions come from? So source identification is our next big chunk of the puzzle that we will look at. So we will start with something called emission inventory. That is, it is the foundation of developing source apportionment. So source apportionment is where you say this X% of this emissions is coming from this source. So it's the foundation for developing emission inventory and therefore mitigation control strategies. So what you ideally do is you list down all the emission sources in a given study area, and you find out what is the total emission load. So this formula, which is, some of you must have seen this, its total emissions is nothing but a function of activity rate, emission factor, and overall emission reduction potential. This is the US EPA definition. There is also the CPCB guidelines for emission inventory, which gives not only the list of emission factors and also methods, but this is the one that should be used for cities under the National Clean Air Program. And I will touch base upon that in a bit. So let's take the city, Indore. This is a smaller, much tighter emission inventory. What is done is the city is then divided into grids of a certain resolution. This is a 500 into 500 square kilometer grids. And then in each grid, we try and find out what are the possible sources. The most obvious suspects is what we have listed here. So there is vehicular pollution, and we try and do surveys to find out what is the fleet-wise count, what are the major roads, and what are the fuel stations, and we do a survey. There is domestic emissions coming from cooking fuel. There is emissions from garbage burning. There is emissions from eateries, where you try and find out what is the number of restaurants, what is the type and quantity of fuel they are using. There is the obvious industry that everybody knows, but in cities, as more and more we see, industries are getting pushed out of the city. But if it's within the city boundaries, or it's smaller, the small cluster units, or the MSMEs, as we call them. So what is the number of these clusters? What is the type in each grid? And what is the amount and type of fuel used? Another very, very major source is road dust and resuspended road dust, which also comes from vehicle movement and construction and demolition waste. So India has this huge splurge of infrastructure projects. So somewhere there is a lot of breaking down and building up happening. And that is development. We are a developing country. We need that. But that's also a source of emissions. And there is crematoria and other such sources. So the way we calculate is, for each of these sources, there is an emission factor available. And then we try and find what is the total emission. So it's fuel type into the emissions emission factor, and you get the total number of emissions. So here I have something for cook stoves. Similarly, we will have something for each type of sources, and within each sources, for example, for each vehicle type, we will have different type of an emission factor. For each fuel type within, let's say, open eateries and restaurants, kerosene will have a different emission factor, coal will have a different emission factor. So like this, you estimate the total amount of emission load coming from each type of source within the city. So once this is done, I want to touch upon vehicular emissions. It's a slightly different method. You have the VKT method, that is the vehicle kilometer travel. What you do is, within your city boundaries or within your grid, you find out what is the total number of vehicles that are traveling of a particular mode, and what is the total average kilometers it's traveling per day of the same type of mode, and you get the VKT. Now, you have different type of cars, right? Or you have different types of fleets moving in a city. So for each type of fleet, you find the VKT of each type, and then use the emission factor for that. So as I said, the emission factor for freight or a type of truck, or even a BS4 versus a BS6 vehicle, will be different. So you multiply that with the emission factor, and you get the emission load for that particular type of vehicle. And then you add them to get the total emission for your cars. So it's a complex process, but it's done. And this is what all cities have to do under the National Clean Air Program, is develop their own emission inventory. What emission inventory gives is that what is the total amount of load of emissions coming from a particular source. However, we also know that there is an impact of meteorology, which is very, very strong. So for that, so before I jump to that, I want to talk about this. So as I said, you divide your entire study into grids. And then once you've done that, once you've done your surveys, you can actually point out what is the main type of source in each grid. So this is just a very quick and dirty, this is not the actual, this is work in progress. So the same city we have divided into grids, and we now see that this portion will have more of domestic emissions. This portion will have a lot of domestic as well as industrial emissions, because there are welding stretch. This portion will have emissions from crematoria. Like this, you find out for each grid, and you develop source profiles for each grid. After that is done, we do something called dispersion model. Now, this is complicated, and I don't expect people to understand this very, very quickly. But what we are doing is we are trying to map the emission activities in the study area, as we have found out, and correlate them through probable sources. And the model that I'm showing here is AirMod. This is just one of the many models. There will be more. There is CMAC, which has a higher resolution. So each model will have its unique inputs, outputs, and characteristics. So for AirMod, what you can do is, once you input the meteorological data, once you input the emission inventory, you can actually quantify the source for each quantify the emission load for each source. What AirMod does not give, is it does not include chemical speciation. So it's totally a physics-based model. So if the pollutants are reacting with each other, and if that is leading to a change in sources or change in quantities, that is not something that is detected in AirMod. But nevertheless, this continues to remain fairly popular, and dispersion modeling is very well used for source apportionment. Dispersion modeling is a form of source apportionment that forms a bottoms-up approach. That is, you're going from sources to concentrations through modeling. The other option, which is also very popular, is receptor modeling, where you're going from concentrations to sources. Here, instead of starting with an emission inventory, we start with measurements. We do sampling across various sites across the study domain. And then we measure the different species. And once we have the sampling and the source characteristics, we run them through a model. The way it works is each source will have certain chemical characters, certain chemical signatures. And then we try and match what is the chemical signature and then come to our final sources. A question that is often asked is which one to use, receptor versus dispersion. I don't think there is a straight answer. The answer is that each model will have its own. Of course, receptor modeling is more expensive to run. There is a laboratory component to it. But both will give oftentimes different type of answers that we are looking for. And when there is enough finances available, like for Delhi, there are studies of both receptor and dispersion modeling. And another thing to remember is all this has to be done for every season, because the measurements will change depending upon the season and meteorology. So this is a major portion, and I know this is not something that you take in very quickly, but let's kind of put this all together in a bigger picture. So we start with monitoring. We start with hybrid networks or real-time monitors, manual networks, whatever we have available. And then after you have the numbers, there is emission estimation. That is, you can do it at the national level, you can do it at the city level, and you can also do it at the hyperlocal level, that is localized emissions, which is far more tighter and far more higher resolution. Then you do the same for quantification. You take the results of emission estimation and you quantify, and you model the concentration, and you check what is the contribution of each source within your study area. And based on that, you develop your action plans and you plan finances and implementation. For example, if there is a result, let's say that 70% of an area, the pollution is because of vehicles. So there is a push for, let's say, tighter fuel economy, tighter fuel standards. There is a push for electrification. There is a push, if possible, for low emission zones. There is a push to change the mass emission standards like we have for all of India, moved from BS4 to BS6. But all of this requires a certain degree of implementation and policy instruments, and of course, a lot of finance. And that is where this part comes in. In all of this, while all of this science and policy and everything is going along, there is a very strong element of communication, and which I've come to believe that there is a lot of noise. For example, in India, we talk of pollution from October, and then by February, it quietens down. And these are the somewhat lean months. And then in August, because it rains, the pollution is really low because rain and meteorology washes off everything. So we believe that we are not polluted at all. We are a clean country. And then again, the cycle starts. I feel this needs to be changed. One needs to understand that there are some sources that are active throughout the year. And it's only in the months of October, November, the situation gets heightened because there is some kind of other types of burning happening, as well as the meteorology is very different. The meteorology acts as an enabling factor for pollution to spike. And secondly, a lot of the stuff that I have said today, I agree, is also not very, very easy. So I tell this to myself, and this is not something I have coined, though I would have loved to claim credit, is de-jargonize to decarbonize, explaining it simply to people on how the science of pollution works, and not just blaming a state or a particular community for a certain kind of pollution. And that will help us as citizens take ownership on what all can be done, and also make them understand that it's always better to stop the pollution at source than do mitigation after the sources have, sources has emitted. So communication science communication, I believe, at least in the sphere of air pollution, is very, very important because it impacts all of us. So what are our policies? So we've understood, we've talked about the science about air pollution. We've talked about, at least when I say science, I will only say we've talked about modeling and measurements. I've not talked about atmospheric chemistry, but what happens to the policy instruments that are available to us and what are the legal mandates? So I want to begin by something called the National Clean Air Program, which has been around for a few years. And it is the first pan-India collaborative multi-scale approach by the government of India. There is coordination between state governments, city governments, local bodies, and central ministries to reduce air pollution. It began in 2018 and 2019, and the target that is set, that is reduction of PM10 levels by 20 to 30% by 2024 from the 2017 levels. This target has now been revised that by 2026, PM10 has to come down by 40% from the 2017 baseline. Where does NCAP get its legal teeth? This is for the Air Act, that is the Air Prevention and Control of Pollution Act of 1981. And this gives the government power under Section 16(2)(b) to execute a nationwide program. So that's the genesis of the NCAP. How does the program work? So there is a central monitoring committee set up at the MOEFCC and at the chief secretary level at the states. And there are technical institutes that have been identified for knowledge support. So as far as I know, IIT Gandhinagar is also one of the institutions for the same. And at the city levels, earlier the state pollution control boards were responsible for developing these action plans. But now for implementation, the urban local bodies have been given the job of implementation, and there is a budget for it. So the initial budget was rupees 10 crore for a city of 5 to 10 lakh population. And however, in about 2021, the 15th Finance Commission sanctioned a huge amount of money to the cities. NCAP identifies something called non-attainment cities. And I will start with the good news. Gandhinagar is not a non-attainment city. Most of us are, I think we live in a non-attainment city. So these are about 131 cities across the states and union territories. And initially there were 102. Later on, they were added, and these include some million plus cities. How have we come to identify non-attainment cities? This is where PM10 and NO2 levels have exceeded limits consecutive for 5 years, 2017 and before that. And they are and some of these are combined with WHO's list of cities with very high PM2.5. There are about, as I said, 131 cities. Maharashtra has 19 non-attainment cities. Uttar Pradesh has 17. And then there are some states like Goa that is Punjab, so it's 1. Gujarat has 4 non-attainment cities: Surat, Ahmedabad, Rajkot, and Vadodara. What we have to do, what these cities have to do, and they've already done, is they have developed these action plans, which are sector-specific strategies. And there are targets to reduce PM10 levels based on these strategies. Funding has to be allocated, and the implementation, as I said, is now moved from the pollution control boards to the urban local bodies. Now, this is a challenge because urban local bodies, as our municipal bodies, traditionally don't deal with air pollution. But this is also, I believe, an opportunity for them to build their capacity because they have a lot of teeth otherwise. Every city has municipal bylaws, so they have a lot more legal teeth to look at pollution. The finances are allocated by the 15th Finance Commission. There is an upfront money that was given to cities when the program started, following which there are performance-based incentives depending on how much has been the reduction in the particular city. And each state and city has to submit reports every quarter to the central government and NGT. So this is NCAP, which is where it started, and it's been a massive program, and that is what primarily looks at air pollution right now. What we also, prior to this, we had the Air Act, which was the Air Pollution and Control of Pollution Act in 1981. It was amended in 1987 and included noise pollution. This was the central act that is crucial for developing framework for all air pollution regulation in the country. This is the one that gives teeth to our PCBs, and this is the one that defines the offenses. The problem with the Air Act, it's not a problem, it's just how it's designed. is that it has very little cognizable offenses. That is, you can pollute, there will be a court case, there might be a criminal court case, but no one's going to jail. So it's non-cognizable for the better part. And that does not act as a deterrent. So that is a problem. Center for Policy Research has this wonderful diagram of how the AIR Act has evolved. And as I said, the standards came in 1998, 2014, the Ambient Air Quality Index was launched. And then you had the categories and industries, and then the deadline to implement city action plans under NCAP. Currently, where are we with the NCAP? As I said, it's 2023. This was launched in 2019, 2020. There is a Prana portal, which is run by KPCSD, where you can actually go and check if you live in a non-attainment city, or if your hometown is a non-attainment city, you can actually go check what has been the progress, how much funds have been spent, and what has been the action taken for each specific sector. You can also check the financial resources that have been allocated. And now there are performance incentives, and cities are actually ranked based on performance and how well they have done under the NCAP. At the central level, we have now institutionalized the Commission of Air Quality Management. This takes over from the erstwhile EPCA, Environment Pollution Control Authority, or EPCA, which was a Supreme Court mandated body. So CAQM has the power to give directives for managing air pollution across all of India, and specifically in Northern India. So there has been a lot of policy aspects. And as I said, there is a lot of development on monitoring. It all has to come together for cleaner air. So the question that I am asked by my relatives is, or people that I work with, is clean air really possible? I say yes. What you see here is a picture of Mumbai that I took right before the lockdown. This was in 2019, late 2019, December 2019. And this is at quite a height. This is at a higher level hotel. And this was, of course, taken by a well-known photographer. And this is from the internet. And this is during the lockdown. This is 15th April 2020. And you see AQI has come down. The skies are absolutely blue. And I did the math for this, and I checked levels from the free data that's available by KPCSD. And we saw that there was a 63% reduction in NO2 and PM10 levels. And means that the target set under NCAP for Mumbai is about 48%. If you look at the 2017 levels, that's genuinely possible. And the only way that's possible is shutting down, or only way that's possible is attacking pollution at the source. So the question one asks is, what do you do? Shut down the economy? Of course, that's not possible. What we do is we find sector-specific solutions, and we have clear mandates of what to do. So clear mandates for coordination between government departments. For example, the Pollution Control Board has to work closely with the Transport Department and the Industries Department to have mandates for pollution control devices in the industries. It has to be a multi-pronged approach for transboundary action, city-level action, and hyperlocal action. So air, as you know, cannot stay in one place. So you can put a barricade between Delhi and Gurgaon, or Delhi and Noida, and say that, oh, you need to pay a toll and get through. Air doesn't need a toll, it just moves. So it moves from upwind to downwind, and depends on where you are along the path of the air, you get your brunt of pollution. So if, for example, if there are industries in one state and the state downwind is getting the pollution, there has to be coordination. So that's transboundary action. At a city level, that is what city action plans are doing. There has to be action at the municipal body, and also a hyperlocal strategy. Lately, that what we've been seeing is there are these pollution hotspots within cities that are different from the entire city. So if you have a certain area in a crossing in Delhi, the pollution, the AQI is well above 480. But if you move away a few kilometers, and I'm saying few, it's not much. If you move away a few, 4 or 5 kilometers, the AQI has come down to as low as maybe 100 or 150, which is poor, but it's not 500. So what one needs to do is identify what are the and that cannot be due to meteorology, that cannot be due to transboundary. That is probably due to sources combined within that hotspot. So we need strategies for hyperlocal action. Overall, increase in awareness, increase in capacity, and that is why we have these series for students, training and testing of newer monitoring techniques, testing of hybrid methods, and a strong legal framework for enforcement. What we have right now is we have a lot of evidence that there is pollution. We have a lot of evidence to build the case on how to reduce pollution. And then we will have evidence on if you do this, you will reduce. What we don't have is a very strong enforcement strategy that if you have gross polluters, how can you punish them to deter them to not do this again? And that is something that needs to be developed a little more. And with that, I will leave you with some reading material. We have some emission inventory reports that you can look at. Please feel free to explore Prana portal, know a little more about Breathe London and mobile monitoring. If you plan to work on sensors, there is an LCS network. How do you set up? And source apportionment, there's a very fine and fun document by Dr. Sarath Bhutikunda, something that you might want to look at. And with that, this is our Global Clean Air team. Please feel free to write to us, and I'm happy to take any questions. And thank you.